guys, Mr. Moore. Just getting ready to go through your first lecture. I'm going to walk you guys through this. I'm going to show you how to take some notes. You can take notes however you want in the future. I'm just showing you kind of how I do things as far as an outline. I think it makes it a little easier for you to get back to study and understand exactly what we're trying to do. So, let's get started. This is going to be Unit 1, Lesson 1. It is on geography. Okay, so when I start my notes, I'm going to switch here. I'm going to start at the top and just write Unit 1. Okay, Lesson 1. Okay, and then I'll write geography. Easy enough, right? Okay, now I'm going to go ahead and start with the lecture. I'll jump back to this page every once in a while so that you guys can see exactly what I'm writing as I'm working through this. And once I get to the bottom of this page, I'll quit taking notes and just get through the rest of the lecture, and you guys can continue to do notes however you want. I will emphasize that you can draw pictures if you want to. I think that's very helpful. The main idea here is to get the main topic of each slide, and if you can identify that keyword, what it's about, and then give some supporting details. Okay, so you'll see what I mean here. Okay, so we're talking about geography. Geography is the study of Earth. Okay, this is where social studies gets into this science area. Okay, we talk about a lot of different things, but this is more like the science part of our social studies unit. So geography, what we're really looking for here, the key concept is how does geography influence the way people live? Okay, you've got some vocab words. We've already gone through the vocab. You guys have seen how to do that, so you should know what these words are at this point. Okay, the sun. The sun is just one of hundreds of millions of stars in our galaxy. Because the sun is so large, its gravity causes the planets to constantly orbit or move around it. Okay, so I'm going to start out with the sun. I'm going to write the sun right here. Okay, and it is one of millions. Okay, and then I'm also going to say that it has gravity which allows planets, or drop this down actually, planets to orbit. Okay, so I've kind of put this into my own words here, right? I'm not writing everything word for word. Okay, well, let's go on to the next one. Okay, life on Earth could not exist without heat and light from the sun. Okay, so that's another supporting detail. A couple supporting details there. So, supports life on Earth by providing light and heat. Okay, pretty good. Okay, without the sun, Earth would be cold, it would be dark, it would be a lifeless rock floating in space. Okay, I like this graphic here. It shows solar radiation. Solar radiation just means that this is the heat that is radiated by the sun onto Earth. Okay. All right. Earth makes one revolution or complete trip around the sun in 365 and 1/4 days. This is what we define as 1 year. Every 4 years, the extra fourths of a day are combined and added to the calendar as February 29th. A year that contains one of these extra days is called a leap year. Okay, so leap year only happens every 4 years, and a leap year is really just one day. Okay, but we add that day on at the end of February. Usually February has 28 days. We add that on as February 29th, okay, so that we make up for those quarters of a day. Okay, so a year really isn't just 365 days. We also have a quarter of a day in there, and they just add up every 4 years. Okay, so let's take a note on that. Okay, so Earth, okay, makes one revolution around the sun in 365 and 1/4 days. Okay. The 1/4 days make a leap year. Every 4 years. Okay, and that is added as February 29th. Okay, so you guys kind of see what I have going on here. Main purpose of the slide, main point, okay, the subject, okay, the supporting details. I may have one slide, I may have 16 slides, okay, that give supporting information on this main point right here, okay. Next point, right, Earth makes its revolution in 365 and 1/4 days, okay, and then supporting detail, okay, about leap years, right. So you guys can kind of see how I lay out my notes. If you want to draw a picture, okay, here's the sun, right? Okay, and then here's Earth, and Earth goes around the sun in 365.25 days, right? Okay, so you can kind of see how you can use pictures, you can do all kinds of different things to take notes. These are your notes. These are important to you and what you're trying to accomplish. We sometimes use notes for tests. You can use them for study. Sometimes I do not let you use your notes for tests. But right now, being at where we are with the year, it looks like you'll be able to use notes. I can't really stop you, but that's okay. I want you guys to get used to using your notes so that you get used to taking good notes, okay? So I'm going to go ahead and continue on with this, this lecture. You guys can finish out your notes however you would like, but I just wanted to show you how to get started. All right, so let's move on here. All right. As Earth orbits the sun, it rotates or spins on its axis. Okay, an axis is what? It's an imaginary line that runs through the center of Earth from the North Pole to the South Pole. Okay, so I think of a globe, right? You guys have all seen a globe. It actually has a physical rod that's holding it from north to south, right? Okay, that acts as an axis for a globe. It's the same thing when we're talking about the real planet. There's just an imaginary axis, okay? Earth completes one rotation every 24 hours or 1 day, okay? So this isn't revolution around the sun. This is one rotation, okay? So it's the spinning of the Earth, okay? So the Earth will spin as it rotates around the sun, okay? So the spin is what we're talking about, okay? Each time it spins, that's 24 hours or 1 day, okay? The part facing toward the sun, okay, that experiences daytime. Okay, so if you're facing the sun, obviously the light from the sun is shining on you. That's daylight. Okay, when you're facing away from the sun, okay, that's nighttime. All right. Okay, the new main point here, right? Inside the Earth. Okay, the inside of Earth is made up of 3 layers: the core, the mantle, and the crust. Okay. You'll actually see this divided up a little bit differently. I've got a graphic on the next slide that shows we've got this other part to the mantle. The core actually has 2 parts to it, but we kind of break it up into 3 main layers. Okay, the center of Earth, the core, is divided into a solid inner core and an outer core of melted liquid metal. Surrounding the outer core is a thick layer of hot, dense rock called mantle. Okay, here's that picture I told you about. Scientists have developed an accurate picture of the layers in Earth's structure. One important way that scientists do this is to study vibrations from deep within the Earth. Vibrations are caused by earthquakes and explosions underground. From their observations, scientists have learned what materials are inside Earth and estimate the thickness and temperature of Earth's layers. So you can see in the graphic, we've got the crust or outer crust, right? Okay, that's where we live. Okay, the upper mantle and the lower mantle. Okay, the outer core, which is liquid, and the inner core, which is solid. Okay. All right, new concept here, new main idea. The air we breathe is part of the atmosphere. The atmosphere is the thin layer of gases that envelop the Earth. The atmosphere is made up of about 78% nitrogen and 21% oxygen, and small amounts of other gases. This is why it's hard to breathe if you're in outer space, right? You can't breathe 78% nitrogen, okay? It would not work for you. Outer space begins at 100 miles above Earth, where the atmosphere ends, okay? Something kind of interesting about this idea here is that there's some argument about where Earth's atmosphere actually begins, okay? So they consider outer space 100 miles beyond our atmosphere, but there is some argument as to where atmosphere actually begins. So depending on where you are on Earth, some consider this outer space when you lose that gravitational pull of the Earth. Okay, that's how they kind of came up with this. It's kind of an interesting thing. If you are interested in that, you might want to Google it. There's some pretty cool articles and videos and things about that you can check out. As Earth orbits the sun, it stays in its tilted position. Okay, if you've ever looked at a globe, usually they're tilted on that little rod that holds them, right? The reason for that is because the Earth is tilted as it sits and rotates around the sun. Okay, it orbits the sun and it stays in this tilted position. This means that one half of a planet is always tilted toward the sun, while the other half is tilted away. Okay, the result is Earth has a northern and southern hemisphere that experience seasons at different times. Okay, so you can see in the graphic there, the top half, or the northern hemisphere, is pointed more directly towards the sun, and the southern hemisphere, okay, is away, so it's experiencing winter. okay, whereas the northern half is experiencing summer. Around June 21st, the North Pole is tilted toward the sun. The northern hemisphere is receiving the direct rays of the sun. The sun appears directly overhead at the line of latitude called the Tropic of Cancer. This day is the summer solstice, or beginning of summer, in the northern hemisphere. Six months later, about December 22nd, the North Pole is tilted away from the sun. The sun's direct rays strike the line of latitude known as the Tropic of Capricorn. This is the winter solstice, when the winter occurs in the northern hemisphere and the summer begins in the southern hemisphere. Okay, midway between the two solstices, about September 23rd and March 21st, the sun's rays are directly overhead at the equator. These are equinoxes. Okay, equinox meaning equal, when day and night in both hemispheres are equal length. 12 hours of daylight and 12 hours of nighttime everywhere on the earth. Okay, so that's what the equinox is. Factors that influence our climate. How do elevation, wind, and ocean currents, weather, and landforms influence climate? At all latitudes, elevation influences climate. Okay, this is because Earth's atmosphere thins as altitude increases. In other words, as you go up a mountain, the air thins and the the air becomes thinner. Okay, temperature decreases at that point when the air becomes thinner. The movements of air and water help create Earth's climate. Moving air and water help circulate the sun's heat around the globe. Okay, here's a graphic. A high elevation will be colder than lower elevations at the same latitude. Okay, so this could be Denver, right? If you get to the west, there's mountains in the west, and you're typically about the same latitude on a globe, but because you're at a higher elevation or going up to a mountaintop, okay, then your altitude increases and the temperature decreases because the air gets thinner. Movements of air are called winds. Winds are the result of changes in air pressure caused by uneven heating of Earth's surface. Okay, so we talked about those solstices, the winter and summer, right? We talked about how the Earth rotates. Obviously, it cools down at night because we're not facing the sun, right? So this causes uneven heating of the Earth, and when we have wind, okay, that wind can either be warm or cold. As you can see from the graphic here, most of the cold wind comes from the polar regions, okay, the North and South Pole, whereas much of the warmer wind comes from the equator. Okay? Just as winds move in patterns, cold and warm streams of water, known as currents, circulate through the oceans. Warm water moves away from the equator, transferring heat energy from the equatorial region to higher latitudes. Cold water from the polar region moves towards the equator, also helping to balance the temperature of our planets. Okay. Weather is what you can observe anytime by going outside or looking out a window. So on a day-to-day basis, we usually talk about the weather. You can look outside and kind of see what the weather looks like at the time, right? Okay. Climate is the average weather condition in a region or an area over a long period of time. Okay, so we collect data every day on what the temperatures are, and from that data, we can gather information and presume or estimate what the climate or averages are, okay? And based on the averages, we can do weather forecasts or predictions, right? So that's the difference between weather and climate. Rainfall and snowfall are types of precipitation. Precipitation is water deposited on the earth in the form of rain, snow, hail, sleet, or mist, fog. Okay, a lot of times we get fog down by the river in the mornings, and that's a form of precipitation. Measuring the amount of precipitation in an area for one day provides data about the area's weather. Measuring the amount of precipitation for one full year provides data about the area's climate. Okay, so we're looking at 365 and a quarter days, and that's how we get climate, not just looking at one day and assuming that every day is exactly the same kind of weather, right? Okay, rain shadow. Rain shadow is a region of reduced rainfall on one side of a high mountain. The rain shadow occurs on the side of the mountain facing away from the ocean. I like this graphic because it shows the Rocky Mountains. If you were to look at the right side of the graphic, okay, or the east, that's where Pueblo would be. And you notice there's like dry grass over there, right? That's pretty accurate when it comes to Pueblo's weather. You can see on the west side or the left side of the Rockies, okay, that's where most of this rain falls. Okay, so as clouds gather over the oceans and move inland with the winds blowing them towards the Rocky Mountains, most of that water falls on the western slope, okay, and we're a lot drier on the eastern slope. That's what we call a rain shadow. And that's it for today. So I am, get myself up here. All right, guys. I know it's a little bit of a crazy scenario this year. It's a tough start, and I think you'll get the hang of this. It's a little easier sometimes for me to show you guys things in class and discuss these things, and so it's a very different situation with us not having so much discussion. But what I would encourage you to do is get on our Zoom meetings on Tuesdays and Thursdays. That starts at 8 o'clock in the morning. You'll all have that code. It'll be posted in Schoology as well. Or you can also get on, I'll post some discussion points, and you can discuss topics with me there if you guys want to participate in that. I don't think I'll make any of those mandatory, but if I'm not getting any feedback or no one's checking in on Zoom, I might make some of those mandatory for you. So I look forward to getting to know you guys a little bit, and that's one of the fun things for me is getting to know you. So I hope that you guys will participate. Keep your notes. You're going to write all your notes in your spiral notebook, okay, along with your vocab, right? At the end of the week, I'll have a survey question I send out to see if you've done your vocab and if you've done your lecture notes. Okay, and what I'll have you do is probably just submit a very short video on Thursdays or Fridays, one day a week. Okay, and I'll have you just flip through your pages for me. You can use your phone, computer camera, and you can just show me all your notes by flipping back and forth through them real quickly. Okay, and that just allows me to see that you guys are doing the work. So I will see you soon, I hope, and you'll be catching another video from me tomorrow. Have a good one, guys. Have fun.